Some time ago, I was interviewed by a company working on a very interesting project. I really liked an idea behind their product, which is just take unstructured input data, extract useful information from images, analyze it, make it searchable, and then use AI for reasoning over the data. So I decided to create the idea myself, just for fun. So meet Savorium. It's a demo project which turns paper grocery receipts into structured and searchable price history. So we just upload a receipt, and then we use vision model to extract shop and items information from the receipt. Then we make items searchable. Then we compare prices across shop over the time. And finally, user can use chat advisor using natural language questions just to ask about their purchase history. For example, how much did beer cost last time? Why I found this project interesting? So first of all, I have created layered architecture, like a real layered backend, where we have a web application firewall as our main entry point, which then protects gateway, which then distribute requests among couple API instances, and then it's API who is responsible for the talking with the storages. And as a storages, we use Postgres for relational or for operational data storage. Then we use RustFS as S3 compatible objects storage. Then we use Redis for caching, TypeSense for search. We use PGV or Postgres vector for the for our RAG solution. Also, we have huge amount of workers which are responsible for scanning receipt, for processing receipts, for reconcile search engine, and for analyze data for the RAG solution. Then as our main reasoning model and for our main vision model, we use OpenAI. Entry points for our solution is, first of all, is a web application with a web browser. Another one entry point is a Telegram chat bot, which we also host. And finally, very interesting and amazing entry point is MCP service, which we use later in the demo. Simplified version of the complete project architecture looks like this. So we have web application firewall is our first line of defense. We use Pingora behind this WAF. And we use YAML hot reload rules to protect our API. Then we have a gateway, which acts as a thin layer to forward requests to a couple of API instances. Then we use standalone identity server to do OIDC authentication. We use RAuth for that. Also, authentication service has its own database, and none of the authentication rules are written at the API level. Then we have our storage services, like we use Postgres as our source of truth for the transactional data. We use S3 compatible RustFS. Then we use Redis as our requests caching engine. We use Redis to cache search requests. And finally, we use TypeSense as our main search server. So let's try our web app. What I have here is a web app hosted in web. I will try to log in with test user account, And what we immediately see, we are redirected to the IDP service. I will use test user account to log in. Okay, cool. And what we have here is UI, for example, to upload a receipt. So let's start with uploading some test data. I will use, for example, this receipt and upload. What we can see here is receipt status. Right now it's in uploaded state. We need to wait some time till the receipt will be recognized by the AI vision model. To track the progress right now, we can check our scanner service logs. Okay, that's logs for our scanner, and our scanner found that this is a shop address. We have couple items, and we basically extracted data from one receipt. Let's check status here. Okay, it's processed. Just for testing purposes, let's upload couple more receipts, like this one, and probably another one. Let's wait some time for these receipts to be scanned and recognized. Okay, let's refresh our receipts page in order to grab recent states. Everything is processed. And what we can try search over the data inside these receipts. So let's, for example, search something like this. And what we can see, we have 3 different shops with beer purchased by someone. And here are recent prices. For example, this one from Mercadona, this one from Corte Inglés, and we have prices. Cool. It is just a simple CRUD solution, but can we make like a natural language communication with our data? For example, here on a chat page, let's try to talk. Something like, I'd like to get some cerveza. Do you have latest price? Okay, cool. So our chatbot answered that we have a couple of purchases with a beer in couple shops. Okay. Show me receipt from a specific shop. Okay, cool. And here is receipt. Beautiful. Even we have rate of our similarity results. Okay, let's some other data from receipt. Okay, let's ask what is most cheap beer. Okay, here we have the most cheap beer. Okay, show receipt of it. 78 cents. Here it is, 78 cents for a can. Good. Chat is awesome. Now, when we have chat inside our web application, is it possible to use other chat solutions? Yeah, probably. For example, let's check Telegram bot for the same functionality. What I have here is my bot. I have little menu here where we can start with some interactivity with a bot. First of all, let's once again just upload some test data to the application, but this time via the Telegram bot. So I uploaded a picture or image of a receipt. I see it's uploaded and started processing. Let's wait for it to be processed. Now I see that single receipt was processed and items now are searchable. I of course will try to upload some more test data. This time I uploaded 5 receipts. Let's wait for them to be processed. Okay, I can see that all receipts were processed. Now let's try to talk via the chat about prices. For example, let's ask how much does cerveza cost? Okay. Right now we are in a search mode, so let's try to do simple search like that. Okay, here is information about beer in our application. Cool. Let's switch to the chat mode and try ask once again. How much does cerveza cost? Okay, the price of cerveza varies slightly. Okay, what is the most cheap one? Okay, show me receipt. Okay, cool. That's the receipt for the. Do you have other receipts? Okay, cool. Yeah. Oh, we have plenty of receipts. That's amazing. It's nice to talk with a bot. Cool. Now let's make a little code overview of how all of this is made. So what we have here is a tree structure of the project where we have our data, our infrastructure code, our sources. And as a source in main sources area, we have couple of long-running services and couple of workers. CI/CD process for that is layered among each individual service. So we have pipeline for the build, test, and publish each individual service and each individual worker. Then I use my little own Docker registry with all the containers I create during the CI/CD process. And finally, in order to roll this out, I use GitOps with a Flux, where in my Kubernetes services I installed the Flux solution, configured it to use for each individual container, and now it automatically rolls out latest version of the image if latest version exists. So that's how my cluster looks like. We can check it here. So here are all running services. For example, we have our database in a container. We have object storage in a container. We have couple instances of the web API. We have web application firewall, gateway, Redis, our logging stack. Let's check some worker, for example, this scanner. Right now it just started, did nothing, and basically stopped. Cron job operates operate by the workers. So what we can see, pods. This is our pods overview. What we have, our cron jobs. We have 4 cron jobs to scan receipt, to process data from a receipt, to analyze or to prepare our receipt for a RAG solution, and to search our to reconcile our search engine. Let's check services. We have a lot of services, for example, for web application firewall. We have service for API, which handles 3 instances of the API. We have another one, API service to distribute load among 3 other API instances. We have our authentication service. Basically, yep, a lot of entry points published locally from my Kubernetes cluster. Yep. Now let's talk about the databases. I have 3 Postgres databases. Savorium DB is something what we use to store our operational data. We have individual database for identity service, and we have individual database for our vector search or for our RAG solution. The funny part is all of this is hosted on my little 3 nodes 3 Raspberry Pi nodes Kubernetes cluster with 1 master and with 2 worker nodes. Now let's go deeply inside the search endpoint. So our search endpoint is something like simple API we can call from a postman. Okay, it's just a version update. Cool. Now we will try to log in with our test user account. Here we obtained access and refresh tokens for my test user. And let's try to search something. For example, let's try to search Cerveza. Yes, we do have some records here. We use Redis and type search for the delivering results. And here in the search source response header, we can see that this response was delivered by a type sense. Let me repeat the same request even a couple times. In this case, in our response header, we can see that result was delivered from the Redis. Cool. Now, as soon as we use type sense as our search engine, it means that we are not limited with just a strict word search. For example, I can mistype the name of my search term, and it still will reason enough to deliver exactly what I'm looking for. I will try to mess with the search term once again. Still good result. Can it do something like this? No, it cannot. And exactly for that, we have a next stage of our project, which is MCPs. Now let's talk about MCPs. So first of all, I will use my local MCP server, and for that I will use OpenCode, for example. When starting OpenCode, I already can see that one of my MCP service is already connected. Let's see what's that. Okay, it's a receipt kit and it's connected. Now let's check models I have. Okay, I have one free model. Cool. Okay, let's try to use our MCP solution here locally. For example, I can ask how much does beer cost in Spain in August. Use local MCP to get price. Okay, we can see that that MCP is connected. We can check our dialog. We can see that receipt search were used with a beer term or with cerveza term. And here is result. So here is searched receipt kit results. And we can see the item, we can see shop name, and we can see exact price of an item taken from the receipt. Cool. Okay, give me the, let's imagine it's beginning of a month and I can buy some expensive one. Okay, here our local here our OpenCode reasoning with a free model reasoning about the data, and it found that I am allowed to buy that one as a most expensive one. Cool, that was local MCP server. Let's jump to the remote one. To demonstrate remote MCP servers, I will use I will use Cloud Code. Here I have my web interface for the Cloud Code, and what I will do, I will connect my connector. Here is add custom connector. I will provide a URI and the name. As we can see, we also need to provide authentication details. I will use OAuth client ID and add my MCP service. We need to authenticate. Let me reconnect remote MCP. It will ask for credentials. I will provide my username and password for that. Cool. My connector is connected. And what I can try, I can ask Claude about data inside my database. For example, how much did I pay for beer in August? Use receipt MCP. Okay, it's connected to my Savorium MCP. I hope it gets some data. Okay, not about beer. What about cerveza? Okay, it knows cerveza. Come on, give me more. How much did I pay for cerveza? Okay, that's much better. So here is information from my receipts. Let's say show the receipt if you have it. Okay, it doesn't have my receipts, probably something we can improve. But anyway, I can use my web Claude code to talk against my local dataset. I believe that's all for the test demo project I would like to create and make a demo and just to enjoy the final result. Thanks.